Okay, so I'm going to be starting with a couple of the questions from the Unit 1 review. First up will be the question 4, and I'll do 4A both parts. Okay, so for question 4A, the first question is 4 raised to the 5th power. It's asking us to have a prime number is the base. Well, a prime number that is related by exponents to the number 4 is 2. So 4 is the same thing as 2 squared, and that's being raised to the 5th power, and an exponent being raised to an exponent is the same thing as multiplying, so this is the same thing as 2 to the 10th, and that is my final answer. The second part takes the number 9 being raised to the 7th power. The number 9, the prime number that it's related to is 3. So 9 can be expressed as 3 squared raised to the 7th power. And then same concept, we're multiplying, so this is the same thing as 3 to the 14th. So that one is question 4. I'm going to go ahead and do number 11 as well. Now, a square-ended cuboid has the volume of xy squared, where x and y are its lengths. A cuboid for which x equals 2y has a volume of 128 centimeters. Find x. So it tells me that the volume is xy squared, and it also tells me that the volume is 128 centimeters cubed. It says that x is equal to 2y, so I'm going to plug that in. I have 2y times y squared is equal to 128. This is the same thing as 2y cubed is equal to 128. I divide by both sides. I have y cubed is equal to 64. Therefore, y is equal to 4. And I'm going to make sure I include my units, which is centimeters. Next, we can take a look. I'm going to skip 18. Y'all should be able to do that one on your own. 5. The next question is 5A. So I will do A, just the first part, and B, just the first part. So we have 5A, I. This is log base 2, x equals 32. Since this is no calculator, I would assume that this is just expecting me to have A is equal to, A is equal to 2 to the 32nd power. However, if not, you can multiply it out. I broke it into numbers that I knew and then multiplied it, but also you can just plug it in. In this case, you're not supposed to plug it into the calculator, so I would assume that it wants me to leave it in this form. The next example would be 5B. And the first one, it says log base 5 of 25 is equal to 5x. That means that 25 is equal to 5 to the 5x. I know that 25 is the same thing as 5 squared. Since the bases are the same, I can set these equal to each other. So 2 is equal to 5x, therefore x is equal to 2/5. Next, I will skip over 6, 7, 8, move to number 10, and I will do part A for you. So 10A. The problem is log base B of A divided by BC. The first thing I notice is that all of my variables X, Y, and Z are in terms of log base 10. Therefore, I have to change log base B into log base 10, which means I need to use my change of base formula. So now I know that this is the same thing as log of A over BC divided by log of B. Now I can rewrite the first part, the numerator. I can rewrite according to the multiplication and division log rules. So this is the same thing as log of A minus log of B times log of C. I know, I'm sorry that ran down on the line. And this whole quantity is having log of B subtracted by it because of the denominator. So my final answer, log of A is represented by X. So I have X minus YZ, and that quantity is minus Y. I don't think IB would take off for you removing the quantity parentheses, but just to be safe, I would leave it there. It can't be simplified beyond that, and I think it's safer to leave the parentheses rather than to delete them. Okay, moving on, last but not least, from the binomial expansion, I've done quite a few of those problems with you, but I'm gonna go ahead and do part 10 since it's no calculator, and I'll do parts A, B, and C. So we have, the problem is finding the first 3 terms in the expansion of 2 plus 3x to the 7th, and it's only looking for the first 3 terms. So I know that I can use Pascal's triangle to find the first 3 terms. You could also use the formula if you want to, but personally I am going to use Pascal's triangle because it's a little bit faster since I'm looking for multiple numbers instead of just one term. So I'm going to go ahead and write out Pascal's triangle. And I'm going to stop there because these are my first 3 terms of the 7th when it's being raised to the 7th power. So now I know that, I'm going to go ahead and move this out of the way. So I know my coefficients are 1, 7, and 21. And then as far as my terms, I know I have A, normally we have A to the 7th plus A to the 6th, B to the 1st, plus A to the 5th, B to the 2nd, and I'm going to go ahead and plug in my A and B from above. So let's start with my A's. I have 2 to the 7th, 2 to the 6th, and 2 to the 5th. I also have my B terms. That would be 3x. There's no B term for the first one. Just one B term for the second one. And 2 for the last one. Of course, I have my plus signs between, sorry. Okay, so then I'm going to simplify. Keep in mind for this one, you don't have your calculator. So you're expected to know what these powers are or be able to figure them out. I know that 2 to the 7th is 128 plus 1,344x plus 6,048 x squared. And I know these numbers seem large, but when you're working them out by hand, it's not too difficult since they're multiples of 2. So I would expect that you should be able to do this. And so does IB, clearly, to do this without a calculator. Okay, so that was part A. But then for part B, they are asking you to find an approximation, of 2.3 to the 7th. So what that tells me is that for this one, x is equal to 0.1. And then for part 2, it's asking us to find 2.03 to the 7th, which tells me that x is equal to 0.01. So now I plug in these x values into the two different equations. Again, you're doing it by hand. The nice thing about 0.1 and 0.01 just means that you are moving the decimal places over. So I will do, let's do the first one. So we have 128 plus I'm multiplying by a tenth, which means I'm only moving the decimal place one place. So it's now 134.4. And then when it's squared, that's the same thing as multiplying by 0.01. So that means this is 60.48. So all of this is equal to 142. Sorry, that's our next answer. When you add all of this together, it is 322.88. Lastly, the second one, when you're to work it out, still 128 because that doesn't have an x term. Multiplying by 0.01, that means we're moving two decimal places, so it's 13.44. And then for the other one, it is moving 4 decimal places because 0.01 squared is 0.0001. Therefore, we're moving 4 decimal places, so this becomes 0.6048. When you add all these together, this becomes 142.0448. Now the last question, it asks which of your answers in part B provides a more accurate approximation, and then it asks to justify the answer. Now the correct answer, the one that is more accurate, is the second one. So this one is more accurate. And the reason why is because a smaller value for x means that when you raise it to a higher power, it will get smaller and smaller. Therefore, it has a less of an impact on the final answer. So for example, we moved this term here was multiplying by 0.0001. It made the numbers smaller. And since anytime you raise a smaller number to a higher power, the more accurate it will become. You can check it in your calculator if you want to. You can still do that expansion in your calculator now to see how this works, to look at the two different approximations and see how they compare. But it is true that if you need me to explain that one a little bit further, just that explanation, make sure you ask in class tomorrow. But I hope my words made sense, but we can go through that explanation of part C if you need to during class. So that's the end of the questions I'll be doing for the review. If you watch this video, hopefully you don't need me to go over any of these problems other than possibly 10 part C. So I will see you in class tomorrow.